we're here. Alright, so we're going to try and do this thermal expansion experiment. So before doing the actual experiment, I think it will help if I just explain the apparatus a little bit. So the basic idea is this. Over here, we've basically got pots of boiling water. And we're going to connect them by these hoses to these metal tubes. So let's just zoom in. There's 3 of them here, but let's just look at this one right here. This one right here. So steam is going to come in here. It's raised up on a block, and then it's going to basically, any hot water that condenses on the inside will trickle out. So effectively, we're just going to have hot steam blowing through here with no water, hopefully, accumulating inside here. This is just to catch any water that condensed, like I said. Now, what we have right here is a thing called a thermistor. These 2 wires come in here and connect to this, and this is basically a spring clamp that is attaching the thermistor, so it's very tight, tightly coupled to this metal rod right here. This metal rod down here is basically to keep the whole thing stable, to keep these 2 black pieces connected together, but this is floating in here, all right? And so the idea is there's a spring collar right here and another one up here. Now what's happening here is this end is, sorry I keep moving around on you, my bad. This end is not going to move. It's locked into this device, which is locked together by this rod, okay? Now the other end is pushing against this thing. So if it grows, it's going to push on this, and notice the dial moves. Now the reason we have to have this crazy apparatus is we're going to heat this up from room temperature, which is about 20 degrees, up to approximately maybe 95 degrees or 100 degrees Celsius. And so, again, I'm talking in Celsius now. And so when it heats up, we're going to see maybe a change of perhaps a millimeter at most. So I'll give you the specifics of this thing later, but maybe I'll put a meter stick up here. Give me a sec. Oh, here we go. So I need a meter stick, sorry. Let's go with this one. You know, I'm doing the best I can here, people. So let's see, this is about, so right here from this spring collar, which is at the 10 centimeter mark, up here to this one, sorry, oh, it's hitting that steam. Hopefully you can see that a little better now. Let me line this up. Okay, so I'm lined up here at 10. So it looks like it's about 35 centimeters. I don't know, you can judge yourself. But to give you an idea, this is 35 centimeters long. I don't know if this is steel or aluminum or what. You can figure that out. But so you can do a calculation and see how much this thing should grow based on a temperature change from 20°C to about 95 or 100 degrees Celsius. Then you can see how much it actually changes by looking at this dial. Now, to make your life easier, what I want to do is I want to make sure this is set. This is approximately in the middle of the device, so it'll get the average temperature of the rod. Okay? And the way we do that is we use this conversion table. So, okay, I'll explain what those numbers mean in a second. That's good. The idea is, this measures the resistance of that piece of metal. The resistance of this piece of metal here, or this thermistor, changes as the temperature changes. So right now it's 119.4 kiloohms. So let's look on here. Notice the resistance is large when it's cold. What did I say it was? 119 or so? Let's just say it's about 120. So it's about 120, which this corresponds to about 21 degrees Celsius. And notice that corresponds pretty well with what we were seeing on this. So I actually believe this number more than this thing. But this was just to show you that it's working. So as we heat it up, when we get to the end, we won't know the exact temperature, but this will give us a pretty good estimate. So your instructor can get you a copy of this chart somehow, and maybe we can put a link underneath the video if we figure that out. I don't know. But, okay. Now, in order to read correctly, one last piece of information. We want to put this piece of foam over the top like that. That way, this is reading an accurate measurement, so it's not losing heat to the environment, which is screwing up the temperature measurement. So again, we've got this, the main features. We want these spring collars to be set in here, so this end can't move. This has to be pressed up against there, so this part will be expanding and growing that way, pushing the dial around. I'm going to zero this out, so it's going to start at 0. This is in the middle of the rod. It's coupled tightly by the spring collar, and it's insulated from the air, so it's reading approximately an accurate measurement of the average temperature of the rod with this resistance. It's up on a step so that this water out inside won't, the condensed water inside will drip out, and hopefully this will give us an accurate measurement. That's it.